Alright, section 2.5, I have two examples set aside to do for a video for you. The first one here is calculating the interquartile range for this data set, and then drawing the box and whisker plot. So remember, to find the interquartile range, you're going to have to find your quartiles first of all. Remember, we have three quartiles. We have Q1, Q2, and Q3. Q2, remember, is the same thing as your median. Remember, median is your middle number. So here, if we count our values here, we have a total of 8 values. So here in this case, we have this part of our data, and this part would split it in half. So that would mean our median would have to be right in here. Remember to find it if there were two middle numbers, in this case the 17 and the 19. Remember, we have to do that 17, add it to the 19, and then divide it by 2. So in other words, you're finding the average of those two values. So if we do 17 plus 19, and then divide that answer by 2, you should get 18. So remember, that is your median. And remember, your median is the same thing as Q2, or your second quartile. Remember, we need to find that first in order to come up with our lower half and upper half of our data. So we'll label this one as lower, and this one as upper. Remember, the lower half is everything that was below the median. Upper is everything above the median. So if the median is in between two numbers, that means you're including the 17 and 19 as part of that lower and upper half. If the median is one of the data values itself, then you exclude that from your lower and upper half of your data. So it's something to keep in mind, that that median is not actually part of that lower and upper half. So the lower half, you now find the median of that section, or the middle number out there. So in this case, once again, we're going to have two middle numbers, this 15 and 16. So in between there will give us our Q1, or that median of the lower half. So let's write that down here. Once again, to find that, we'd have to do, since there's two middle numbers again, instead of 1, we have to add them together, divide by 2. So in that case, we get 15.5. And since it's the lower half, and it's the median of that, it represents Q1, or that first quartile. Similarly, for the upper half, our median is between the 20 and 21. So we'd have 20 plus 21. Divide that answer by 2. So if we do that, we get 20.5. And that would represent Q3, or our third quartile, since it's the median of the upper half of the data. And keep in mind, just like it said in the book, Q1 represents that there's 25% of the data below that. Q2, there's 50% below that. Q3, 75% above that. Hence why they're called quartiles. Split them into quarters, or fourths. So here, in this case, to figure out then your interquartile range, we abbreviate as IQR, instead of having to write out interquartile range every time. And to calculate that, we just do our Q3 minus Q1. That's why we needed to find those values first. So remember, Q3 was the 20.5. Q1 was 15.5. So in this case, we'd end up with 5 if we do that 20.5 and subtract it from the 15.5. So that'd be for the interquartile range. And then we also want to find the box and whisker plot here. So to do that, we're going to want to set up a scale first of all, so that way we know what the values are representing in our box and whisker plot. So in this case, our smallest value is 10, so we really don't need to go below that. So here, for instance, if you wanted to, you could go up by 2s, you could go up by 5s, whatever you want. Here we'll start at 10 and we'll go up by 5s here. And we want to make sure that we go up high enough to include all of our values. So if we go up to 25, that'll be high enough here since our max value here was 24. Keep in mind here, remember, whenever you're doing your box and whisker plot, that we're going to have our lowest value will be marked as 1 value here. If you want to, you can go ahead and draw a line all the way through until the maximum value right away if you wanted to. And keep them all in the same line. Might help you to keep things organized. Or if you want, you can leave that middle line out in the box part. We'll do it like this, just help keep everything in line. So right now we have this value down here, remember, is your minimum, the smallest value in your data. 24 was the maximum, that's the upper end here. And then the box part has to do with your quartiles. So Q1, the 15.5, is going to be the bottom part of the box. Q3, which was 20.5, is going to be the upper end of our box. So I'll connect those there. And then Q2, which was the 18, is going to be where our line goes in the box. Keep in mind that line for the median is not always going to be right in between the Q1 and Q3 for those two quartiles. Depends on the spread of the data. In this case, our spread is pretty symmetric. It's about the same on either side of that mean and that median there. So that's why it ends up being about the center of there. Keep in mind in the box, if you have a tail, so in other words, if one of those whiskers on the end was far to the left, so for instance, if this line in this section here went out way far to the left, then it would be skewed left. If this line on the right hand side went out way far on the right side, then it'd be skewed right. So something to keep in mind there of how you can use the box and whisker plot to help you decide if it is skewed or not. You can also tell by looking inside of your box as well if part of this is more to the right, then it's skewed right. If it's more to the left, it could be skewed left. If everything looks pretty even, then it's symmetric. Just a reminder on those terms again. So that's for our box and whisker plot. Example 2 here, it's a little bit quicker. This one has to do with your z-scores. So here it says that you got a score of 75 on an exam in a class, and your class had an average of 70 on that test with a standard deviation of 2. Your friend got an 80 in a different class, and that class had an average of 77 with a standard deviation of 1.8. You want to find the z-score for each of your scores and see who did better in comparison to their class. So remember to find a z-score. Keep in mind my z's, I put this little line through it so it doesn't look like my 2's. Just so you know what that symbol is. It's just my way of writing out a z. You do your value minus the mean divided by standard deviation. And of course, that mean and standard deviation is going to change depending on your problem, depending on the situation that's going on. So for instance, here it said that your score, so your score in this case is your value. You got a 75. Subtract from that the mean. Remember, mean is the same thing as the average. So you subtract off the 70 and then divide it by the standard deviation of 2. So in this case, you get a z-score here of 2.5. So keep in mind that z-score really represents that you scored 2.5 standard deviations above the mean. So in other words, you scored quite a bit higher than what most of the students did in the class in comparison. And then here, for your friend, so this one was for you, so we'll write down you beside it to remind you this was supposed to be for your friend. Same calculation, you do your value, so the value of your friend, they had a score of 80, but your friend's class had an average of 77, just the mean, divided by the standard deviation for that class of 1.8. So if we subtract those, we get 3 divided by 1.8 there. So in that case, for your z-score, you're going to get about 1.67. We'll put the approximation since we did round there. So here in comparison, your friend scored about 1.67 standard deviations above the mean. Once again, both of you scored above the mean. You know that it's above because they're positive z-scores. But your score in this case was higher. So in this case, let's circle this, that yours was the higher score in relativity to the class, which is what it was saying here. We wanted to compare results and see who did better in comparison to their class. So your friend may have scored a higher score overall, but in comparison to your class, you did better. So just an idea in terms of how you can use that z-score other than just define the calculation there.